Yeah, so, good evening, everyone. We'll start with the session. So, welcome to the NPTEL live interactive session for week 8 on the course Urban Transportation Systems Planning. So, I am Abhishek Raj, a PM-RF scholar in the Department of Civil Engineering, IIT Madras. So, coming to the outline of this presentation, so we will start with the overview for week 8. So, what were the lectures and topics that were discussed? So, this week was mainly about mode choice. We can say it was advanced mode choice. So, nested logic models, multinomial logic models, and then we will discuss the practice assignment and then we can take some doubts. So, starting with the overview for week 8. So, there were 5 lectures. So, first lecture was about what is the difference between the true utility function and the function which is defined by the analyst. So as we know, so utility function is defined as u plus e. So this is the true utility function and this is what the analyst defines. And e will be the error term. So depending upon our model, we can choose a distribution for the error term. When we discussed the examples of dependence, lecture 2 was about the binomial logic model. So when we are faced with two choices, then how will we select one over the other? So here what do we do is, so probability of selecting choice 1 will be equal to e power v1 by e power v1 plus e power v2, where v is the utility. Then we discussed the properties of logic choice models. Lecture 3 was about the formulation of multinomial logic model. So when we are faced with more than two choices, so it is basically a uh, so we can say binomial logic model is a special case of multinomial logic model. Then independent associative property was discussed, IIA. Lecture 4 was about the examples and the effect of this property and how we can reduce the consequences. So for that, we introduce new modes, and if we introduce new modes, so we can incorporate them using the nested logic model. So for reducing both the effect of IIA and for incorporating new modes, we can use the nested logic model. So this was the broad overview for week 8. So let's start with the practice assignment. So question 1, if the specified utility by the analyst equals the true utility by the decision maker, prediction of mode choices probabilistic, true and false. So can I have some response for this? Any other response?
This is false.
Okay. So as we know, the utility function is given by we define it as say u is the utility function, we can define it as v plus e. So u will be what the rho utility function is, and v will be the utility function which is given by the analyst. So depending upon what parameters he has chosen, he will have his own utility function and e will be the error term. So what we are seeing here is if the specified utility by the analyst equals the true utility by the decision maker. So what we are saying is u is equal to v. So in this case, there won't be any error term. So error term will be absent. So if error term is absent, it will not be a probabilistic estimation. It will be deterministic because we don't have any error. So we can say with accuracy that what will be the mode choice. But since we are saying that the choice is probabilistic, so we need to have a error term in that case. So if this case is satisfied where the specified utility by the analyst is equals to the true utility of the decision maker, so the choice will be deterministic. So we can choose the second statement, which is false.
Uvidya sir, your voice is disturbing. If you kindly check your speaker, your voice is not clear to us. Some disturbance, noise is interruption is noise is coming. Noise interruption is coming.
Okay. Is it better now?
Yes, now it is better. Is now it is better.
Okay. And so I'll just go over it again because if the voice was not clear. So utility function is defined as the sum of the utility function given by analyst plus there will be an error term depending upon the distribution that we have. So here we are saying that utility of the analyst is equal to the true utility of the decision maker. So u is equal to v, so there is no error term. So estimation will be deterministic. But what we are saying here in the question is it is probabilistic. So this statement will be false. So the answer for this question is false. Moving on to the second question. So this is an accept reject type of question. So true utility function is the utility function specified by the analyst. Accept or reject. Can I have a response for this?
It is accept.
Okay. Any response from Vijay? Vijay, any response? Okay, fine. We'll move ahead. So as we saw in the previous question also, we'll just go over it quickly again. So okay. So u is v plus e, u is the true utility function, v is the utility function given by the analyst. So what is true utility function? It is different from what is given by the analyst. So this is the utility function which is used by the traveler or the decision maker. So what he will use is will depend on the analyst's utility, and there will be an error term because the analyst cannot predict accurately what will be the mode choice. So we'll always add an error term for probabilistic estimation. So this is reject. So we can reject the statement because it will not be the utility function specified by the analyst. Both are different things. So this is reject. So true utility function is the actual utility function used by the traveler or the decision maker. Moving on to question 3. If V1 minus V2 increases, then what happens to the probability of choosing alternative 1? V1 according to binomial logic model, where V1 and V2 are the deterministic components of utilities of alternatives 1 and 2 respectively. So we have 4 choices. So what we are saying is the difference of utility is increasing. So what will happen to the probability of choosing alternative 1, that is P1? What will be the effect? So there are 4 options. Option A is P1 will increase, option B P1 will decrease, P1 will remain constant, or none of them. You can try this and let me know the answer. So any response for this? Okay. Let's see the answer. So as we discussed, so probability of choosing alternative 1 will be given by e to the power utility of alternative 1, e to the power utility of alternative 1, and e to the power utility of alternative 2. So here we have only 2 alternatives. So we need to do a little adjustment here. So since we want the term V1 minus V2, so we need to bring this into the denominator so that we get this term. So let's do this as 1, and since we are bringing it, so 1 by e to the power V1, e to the power V1 plus e to the power V2. So this will become 1 by, so this will term will become 1 plus e to the power V2 minus V1. But what we need is V1 minus V2. So let's do again a small adjustment. So P1 will be 1 by 1 plus e to the power minus V1 minus V2. So now we have the term V1 minus V2 in our equation, and this the left side is P1. So depending upon how this changes, we can predict the effect on P1. That is the probability of choosing alternative 1. So let's do this. So if what we are saying is V1 minus V2 is increasing. So if V1 minus V2 is increasing and we raise this thing to an exponent, so it's a simple thing. So if the value of x is 1, y is 2, so e to the power y will be greater than e to the power x. So as the exponent will increase the value. As the value of the power increases, the overall value will also increase. So e to the power v1 minus v2 will also increase. But here we have the opposite of this. So e to the power minus of v1 minus v2. So this will reduce. v1 minus v2 will increase. E to the power v1 minus v2 will increase. The reciprocal of this will reduce. So 1 plus e to the power minus v1 minus v2. So since this term is reducing, this overall term will also reduce. And so this we have is 1 by some denominator. So what we are saying is the denominator is reducing. So if the denominator goes down, the overall value will increase. Okay. So P1 will increase. So that is option. So is this clear? Okay, we will move ahead. So the answer for this is option A, P1 will increase. So I'll simply recall it. So P1 is e to the power V1, e to the power V1 plus e to the power V2. We brought this down, so it became.
Sir, your voice is echo is coming. Echo voice is coming. Actually, it is echo sound is coming. Not I'm not understanding. I do not know whether Vijay is understanding, but your voice is tremendously noisy, sir.
Okay. So what you can do is you can try log out and log in again. So Vijay, is my voice clear? Okay, fine. So 1 plus e to the power v2 minus v1. So we made it 1 plus e to the power minus v1 minus v2. So this term was increasing. So this whole term will reduce. So denominator will also reduce, and finally the overall value will increase. Moving to question 4. So accept or reject type of question. So multinomial probit model is easy to estimate and is widely used. Accept and reject. So you can respond to this. Let me know the answer.
Accept.
Okay. So any response from Vijay? Okay, fine. So as we saw in the mode choice, we have multiple types of model. Depending upon the use case, we will use different models. So here we have multinomial probit model. So the problem with this model is mathematically complex, and therefore it causes a difficulty in estimation compared to the other models. If we see, so this model is complicated and it causes a difficulty to estimate. Here we are saying is exactly opposite. So we are saying it is easy to estimate and is widely in use. So this, due to this problem, this model is not very preferred in many use cases. So we can reject this statement B. And the answer is reject. So this model is mathematically complicated and difficult to use compared to other models. Coming to question 5. So which of the following statements are true regarding assumptions in the formulation of multinomial logic model? Error components are normally distributed. Error components are Gumbel distributed. Error components are uniformly distributed, and none of the above. Can I have a response for this?
Sir, actually, the it can be normal and it can be Gumbel distributed, depending on.
Okay.
So, so none of the above, I think, sir.
Okay. Okay. Yeah, so if we talk about binomial logic, so there the error term will have a normal distribution. If we discuss this, what is multinomial logic model? So here the error term will have Gumbel distribution. In some cases, we can approximate it with normal also, but mostly, generally speaking, we approximate it with a Gumbel distribution. The special case is where we use normal in my binomial logic. So error components are Gumbel distributed. We can go with option B. So error components are Gumbel distributed. In multinomial logic model, we assume them to be Gumbel or extreme value distributed. Moving to question 6. So which of the following statements are correct regarding probabilistic utility models? In the context of mode choice analysis, these models capture the uncertainties in the travel behavior of the individuals. True utility is nothing but the utility specified by the analyst. Deterministic component of utility function is the observable portion of it, and according to these models, an individual certainly chooses the alternative whose utility value is maximum as per deterministic component of utility function. So you can try it and let me know the answer.
uh, the statement D is correct because according to these models, an individual certainly chooses the alternative whose utility value is maximum. This is the correct statement. And B statement is the wrong statement because true utility is nothing but the utility specified by the analyst. But the utility specified, this is not correct. Uh, Deterministic component of utility function is observed portion of it. Now, I think the you are asking for the correct statements, na?
Yeah.
Statements are correct. D is correct. D for Delhi. According to the last statement is correct, and according to me, I think uh, the statement A, that is the models capture the uncertainties in the travel behavior of the this is also correct.
Okay.
according to me.
Okay, let's discuss each option one by one. So first is these models capture the uncertainties in the travel behavior of the individual. So in these models, what we use is u is equal to v plus e. So here we have a error term. So that error term is the representative of the uncertainty. So we are trying to capture it in the travel behavior. So A is correct. True utility is nothing but the utility specified by the, it is not the analyst, it is the decision maker or the person who is traveling. So the utility function that the traveler uses is called the true utility function. Analyst function is given by V. And this is the true utility. So we can remove B. Then we have deterministic component of utility is the observable portion of it. So yeah, this is true because what we see here, V is the observable portion that we can define using our parameter. So C is correct. So V is the, so what the analyst defines is observable, and the error will be a random component. Finally, we have D. So according to these models, an individual certainly chooses the alternative whose utility value is maximum as per deterministic component of utility function. So what needs to be seen here is that we are saying he will certainly choose. So there is, as we discussed in first option, so there will be some uncertainty due to the error term. So even if we know the analyst function, we cannot say with 100% probability that the individual will only choose this mode, bus or railway, whatever we are discussing. So we cannot say with 100% certainty because an individual given different situation can make different choices which will be incorporated using the error term. So there will be some sort of uncertainty in the behavior. So certainty is not there. We can only say with certain amount of definiteness. So we can remove D. So it's not certain. There will be some uncertainty in that. So A and C are true. So options A and C. So models will capture the uncertainty in travel behavior because we have the error term, and deterministic component is the utility function is defined by the analyst. Coming to question 7, so it is accept or reject type of question. According to multinomial logic model, choice probability of an alternative depends on the difference between the deterministic components of utilities of alternatives in the choice set, accept or reject. So you can try and let me know the answer. Okay. So let's see the answer for this. So we are talking about multinomial logic model. So let's simply consider the equation that we saw some time back. So probability of 1 is given by e to the power v1, the power v1 plus e to the power v2. Let's transform this. So 1 divided by e to the power V2 minus V1 plus 1. So what you can see here is that choice probability. So that is V1. It depends on the difference between deterministic components of utilities of alternatives. So what is the difference between deterministic components? So that is this V2 minus V1. So we can see that the equation of P1 is depending on V2 minus V1. So yeah, what we are saying is according to multinomial logic model, it depends on the difference between the two. So yeah, it depends. So it is accept. So we can choose option A. So option A, accept, is the correct answer because the choice probability in a multinomial logic model will depend on the difference between the utility functions, which is the true utility, analyst utility function, deterministic part. Coming to question 8. So which of the following statements are true regarding error term used in probabilistic choice models? Error term can be easily measured by the analyst. An error occurs in the prediction of mode choice due to the lack of analyst's knowledge on the mode choice behavior of the individual. Error term is always assumed to follow Gumbel distribution. The formulation of different probabilistic choice model basically differs on the assumptions made about the error terms.
B and D. B and D are the states, two test statements. B and D. B for Bombay, D for Delhi.
Okay. Any response from Vijay?
Sir, can I explain? Because A is not correct statement because it cannot be easily measured. It cannot be easily predicted. That's why it is a probability.
Okay.
Second one is that it is the 100% the correct statements because it is the data. Since this is the error we are calling this, since this is due to the lack of the analyst knowledge, so that's why this error always occurring. So this B statement is correct, and error term may be the normal distribution, may be the Gumbel distribution. So C is the incorrect statement. And the last statement D is the formulation of different probabilistic choice model basically differ based on the assumptions. This statement is also the correct statement. So the B and D are the correct statement. True.
Okay.
B and D are true and A or C are false.
Okay. Okay. We'll discuss the answer. So let's see each option one by one. So first is error term can be measured easily by the analyst. No. So it cannot be measured by the analyst. If it could be measured, he will simply say EU is equal to V, because if he can measure the E, he can include the E here. But since we cannot measure it easily, we take it as a separate term and assume it to have a distribution. So it cannot be measured. So we can remove A. Then we have an error occurs in the prediction of mode choice due to the lack of analyst's knowledge on the mode choice behavior of the individual. So yeah, this is true because since we cannot predict with absolute accuracy what will be the mode choice, so we incorporate the error so that we can have estimation with a probability rather than a deterministic estimation. So B is correct. Then we are saying error term is always. So anytime an option has always, so we should be careful. Always is a very extreme statement, so it is rarely true. So here we are saying error term is always assumed to have Gumbel distribution, so we can remove this. It can have normal also, can have extreme value distribution also. C we can remove. We are left with D. The formulation of different probabilistic choice models basically differs based on the assumptions made about the error terms. So yeah, it is correct. Error terms, it can have different forms, and based on the different forms we have different models. That is given here also. So D is true. So option B and D are true. Other two are false. So option B and D, these are the true statements. So an error occurs in the prediction of mode choice due to lack of analyst knowledge because he cannot predict the error term. And the formulation of different choice models basically differs based on the assumptions about the error term. So B and D are true. Moving to question 9. Which of the following statements are false regarding binomial logic choice? It is a specific case of multinomial logic model when the number of alternatives is 2. Probability of choosing an alternative depends on the exponent value of the deterministic component of utility of that alternative only. The probability of choosing an alternative depends on the ratio of the deterministic components of utility of both the alternatives. Finally, we have probability of choosing an alternative is more sensitive to changes in the deterministic component of utility of either alternative when the probability of choosing that alternative is close to 0 or 1. So you can read the question and let me know the answer.
So D for Delhi is false. D for Delhi is false.
Okay. Any response from Vijay? Vijay, okay. B. Fine. Let's see each option. So first is binomial logic choice model is a specific case of multinomial logic model when number of alternatives is true. So yeah, this is true. Let's change the color because. So first let's find the true statement. So binomial logic choice model is a specific case of multinomial logic model. Yeah. So multinomial logic model, we will have basically three or more choices. And when we reduce this number of choice to 2, so what we will get is binomial logic. So A is correct. That is a true statement. Then we have B. So B is the probability of choosing an alternative depends on the exponent value of the deterministic component of utility of that alternative only. So this is where it is wrong. So if we have two choices, our personal vehicle and a bus, so just the choice of choosing the bus will not depend on the only the bus. It will also depend on our personal vehicle's condition and how it is. So if the personal vehicle is not in a condition to move, there is some problem, so we will definitely take the bus. So we cannot say that the probability of choosing a bus will depend on the utility of bus only. So that is not true. It depends on all the mode choices that we are considering. So B we can remove. Then we have C. Probability of choosing an alternative depends on the ratio of the deterministic component. So no, this is not true. It depends on the exponent. So e to the power v1 by e to the power v1 plus v2. So we take the utility and we raise it to the exponents and then we take the ratio. So C also we can select as false. Finally, we have probability of choosing an alternative is more sensitive to changes in the deterministic component, that is V of utility of either when the probability of choosing alternative is close to 0 or 1. So now this is not true. When it is near the mids, like around 0.5. So if you would have seen that graph, so it will be something like this. So when we'll have it around the middle, so that time it will be more sensitive to change, because around near to 0, it will be, the graph will be flat. Near to 1, the graph will be flat. But if we see the middle part, there, like, the change will be very sharp. So D also we can remove. So here we, what we wanted was the false statements. So false is B, C, and D. So option B, C, and D. So B was choosing an alternative depends on the exponent value of the deterministic component of that alternative only. So this was the problem. It depends on both alternatives. Probability of choosing an alternative depends on ratio. So no, ratio is incorrect. We can remove this. So it is e to the power v by summation of e to the power v for all the modes. Let's do this vi v. Then probability of choosing an alternative is more sensitive to changes at 0 or 1. So now it is around 0. Around middle it will be more sensitive, at edges it will not be sensitive. So B, C, and D. Moving to question 10, accept or reject. So if the log sum parameter of a nested logic choice model is equal to 0, then the nested logic model becomes equal to multinomial logic model. Accept or reject. So I'll solve this directly. So here the probability will be of choosing a particular mode. Let's say it will be V plus some theta times of log sum. So what we are saying is log sum parameter is equal to 0. So we can remove this term. So it will simply become equal to V. So we can say that if theta is 0, it will become deterministic choice. And then we can apply any of the model, binomial or multinomial, depending upon how many choices we have. So if theta log sum, we make it equal to 0. So nested logic becomes multinomial. So the nesting part that we did using this term, that we club two modes together, that part is over. It again becomes separate modes, so we can use multinomial logic mode. So we can accept this statement. I think this is incorrect here, so it should be accept. So log sum parameter, just a second. So yeah, it implies zero correlation among the mode pairs, and it will be a deterministic choice. So the model will collapse to the MNL model. So I think here it was written reject, but it should be accept. Coming to question 11. So we have been given mode choices. Three mode choices are there: driving alone, shared ride, and transit. We have the utility functions for all these three modes. We have been given T is the travel time, C is the cost. Travel time is in hour, cost is in Indian rupees, and Y is the annual income of the individual in lakh rupees per year. So it is given here as 5 lakhs. So we want to find which mode has the highest probability of being chosen when alternative specific constants. So that is the first term. So that is the constant terms of three modes are considered by using the logic model. So only three options we can have: drive alone, shared ride, and transit. So we have to find which mode will have the highest probability. So you can try this. So since I taught the formula multiple times, you can try and let me know the answer. So we have the equations. We have the, just a second. The video one more slide. Yeah, so we'll have the table. So here the time and costs are given. Any response? Okay. Any response for this question? Okay. Let's see the answer. Solve it. So we have been given the different modes. So we have drive alone, shared ride, transit. We have the time, we have the cost. Income is 5 lakhs. Yeah, income is 5 lakhs per year. So let's find these three values. So VDA will be equal to 0.7 minus 1.3 into time for DA. So that is 0.4 minus 0.06 cost. So cost is 70 by Y. So Y is income 5. Let's find this value. This is coming out to be minus 0.66. Let's try the second one. So VSR is equal to 0.3 minus 1.3 into time is 0.6 minus 0.06 cost of shared ride 35 by 5. This is coming out as minus 0.9. Finally, the third one, transit. So it is minus 1.3 into T, which is 0.8 minus 0.06 C, which is 20 by 5. This is minus 1.28. So we have drive alone, shared ride, and transit. So all three utilities we have found. Now we need to find the exponent of utility. So let's do that. E power VDA. So this is coming out as 0.5168. Let's round it off at 52. Let's take as E power VSR. This will be equal to minus 0.9, which is 0.406. This is 0.41. And finally, we have E power V of transit. So it is coming out as 0.278, round it off to 0.28. So we need the total also for this value. So total of E power V, which will be 1.21. So now we need to find the probability. So probability for choosing drive alone will be E power VDA by total. So total is basically the sum of all the exponents. So this is coming as 0.429, round it off to 0.43. Then we have shared ride probability. So that will be E to the power V of shared ride by total. So we'll do 0.41 by 1.21. So it is coming as 0.34 around. Last we have probability of transit E to the power V transit by total. Transit is 0.28, total is 1.21. So 0.28 divided by 1.21 is 0.23. So we needed to find the highest probability of being chosen. So highest is drive alone, because we can see here, mark it. We can see this is the highest. So answer is option A, drive alone. So is it clear? Is it clear, Vijay? Okay. We have not done anything difficult. So we had the equation for utility. We had the values in the table. We put the values. We got the utility. Then we found the exponent of utility. We added them. We got the total. And then we can divide that exponent by the total of the exponent to get the probability for each mode. Whichever is highest, we'll choose that. Moving to question 12. So consider mode choice among driving alone, shared ride, transit. So equations are the same. Data is same. So T is travel time, C is cost, Y is annual income. Y is given as 5 lakhs per year. So which mode has the highest probability of being chosen when the constants are not considered in logit modeling? So we have the options: drive alone, shared ride, transit. We have the table. So you can try this. Let me know the answer. This time we do not have to consider the constants. So 0.7, 0.3 will not consider. Then we have to find. Process is same. Any response? Any response for question 12? Okay, let's discuss. So we have been given the functions data. So we have the time and cost, we have the utility function. We have to find which mode will have the highest probability when constant is not considered. So let's start. Change the color. So first is VDA. So we will not consider 0.7 because we have been said that alternative specific constants are not considered. So y is like that one here. So VDA will be minus 1.3 time of DA, which is 0.4, minus 0.06 cost of DA 70 by Y 5. So this is coming as minus 1.36. Let's do for shared ride VSR. So we will remove 0.3 minus 1.3 into time 0.6 minus 0.06 cost 35 for shared ride, income is fixed 5. Minus 1.2. Let's do finally for transit. So in transit we don't have any constant term, we can directly take the equation minus 1.3 time 0.8 minus 0.06 cost 20 by y 5 minus 1.3 into 0.8 minus 0.06 into 4. This is minus 1.28. So we have the utility 1, 2, 3. Let's find the exponents now. So e power VDA, e power VSR, e power VT, point 0.2566. You can round it off to 0.626, 0.301, and round it to 0.3. Finally, we have transit. So minus 1.28. That will give 0.278, which is 0.28. Now we can take the total, which will be 0.26 plus 0.3 plus 0.28, 0.84. Now we can find probability. So probability of drive alone will be e power VDA by total. So e power VDA is 0.26, total is 0.84. This is coming as 0.309, round it off to 0.31. Shared ride e power VSR, e power VSR divided by total. So e power VSR is 0.3 by 0.84. Yeah, 0.3 by 0.84 is coming as 0.357, which is around 0.36. Finally, we have probability of transit e power VT by total. So e power VT is 0.28 by 0.84. This will be around 0.33, I think. It's coming as 0.33. So highest probability is, we can see highest probability is of this one, which is shared, right? So option B. So we can select option B. Mark it here. Shared. Okay. Okay, you have calculated the values correctly. So is it clear? Fine. So simply we have to do in multinomial logic, find the utility, we'll have the equation, we'll have the data. So we'll substitute the values, time, cost, income. We'll get the utility. We'll find the exponent of utility e to the power b. So in a calculator, we have to simply do e power b. So we'll get it. So it will be some value in this, it will be a small value generally. Then we'll take the total of exponents. Then for probability, we'll take exponent by the total for each mode. Then whichever has the highest probability, that will be chosen. Moving to question 13. So data is the same equations. T is our time in hours, C is cost, Y is income. So here we are saying is transit fare is getting increased by 10 rupees. So what will be the change in probability of choosing transit considering the mode specific constants in the utility equations using logit model. So we have been given the value, we have the data. So you can try and let me know the answer. So only change we have done is everything is same, but cost of transit, which is 20, will become 30. So we have to change. Any response? And since there is no response, we'll discuss the answer. So we have the data, we have the equations. Let's start. So here instead of 20, we will also use 30. So let's start with the first one. I will do directly and the values because I did it two times. So VDA will be zero point 0.7 minus 1.3, time is 0.4, 0.06, cost is 70, y is 5. Okay, 0.7. So this is coming as minus 0.006, 1. Let's do for shared ride. 0.3 minus 1.3, time 0.6 minus 0.06, cost 35, income 5. Minus 0.9. Finally, we have transit VT minus 1.3 into time 0.8 minus 0.06, cost. So we'll take 30 because we said that cost has been fare is increased by 10 rupees. So cost is 20 in the given tables, but we'll increase it by 10. So we'll do it 30 by 5. Let's find the value. It's coming out as minus 1.4 values. So let's take the exponents. So e power VDA, e power VSR, e power VT, then we'll have the total. So this is coming out as 0.5168, 0.52, VSR 0.4065, around 0.41, e power VT 0.2466, around 0.25. Let's take the total. Total is coming out as 1.18. So here we only want probability of transit. So let's take it as PT dash, or we can take PT new fare, or let's simply do it PT cost is 20. There will be one new where cost is 30. So when cost is 30, that is the new value. So it will be 0.25, which is here, by 1.18. So this is coming out as 0.21. And when cost was 20, so that we solved in question 11. So let's go there. So question 11, we got the probability of transit as 0.23 with the original cost. So this is the original probability 0.23. So now we have to find the change in probability delta P. So it will be Pt when cost was 30 minus P of t with the original cost 20. This will be 0.21 minus 0.23 minus 0.02. That is the answer. Let's mark it. So answer is D minus. So the probability, we can see that the probability of choosing transit has reduced because the fare was increased. So now someone choosing transit will be less probable because it is now expensive. So is it clear? Fine. So moving to question 14, which of the following statements are true regarding MNL choice models? The ratio of probabilities of choosing any two alternatives remains the same irrespective of the presence of any other alternative. It is difficult to predict the effect of adding a new mode. The change in the probability of choosing a mode due to any reason causes a change in the probability of choosing other modes in the same proportion. And it may be possible to reduce the unrealistic consequences of IIA, associative independent associative property, by adding some additional variables in the deterministic component of utility function. So you can try. I'll give maybe 1 minute. You can put the answer in chat box. Then we'll discuss that. Any response? Okay. Let's see the answer. That's so this is question 14. First option, ratio of probabilities of choosing any two alternatives remains the same irrespective of presence of any other alternatives in the choice set. So yeah, this is true because even if we add other mode in multinomial choice, it will not cause a difference because we are adding it to the same set. It will not cause a difference in the ratio of probability. So here we are saying ratio, not the probability, ratio of probability. So ratio remains the same. It is difficult to predict the effect of adding a new mode to the choice set. No, it's not difficult. So B we can remove. Then we have C, change in probability of choosing a mode due to any reason causes a change in probability of choosing other modes in a proportion same as the original. So what we saw here was ratio of the probability, it will remain the same. So even if we add a new mode, it remains the same. And even if we want to choose like maybe cause a change which causes a change in the probability, so the change will be reflected in the ratio. So numerator will change, denominator will change, but proportion will still remain the same. So ratio remains the same. So C is also true. It may be possible to reduce unrealistic consequences of IIA by adding some additional variables. Yeah. So since we have the effect of IIA in our model, by adding some additional parameters, we can reduce the effect. So D is correct. So A, C, and D are true. So option A, ratio of probability of choosing any two alternatives remains the same. Change in probability due to any reason causes change in the same proportion in the other modes, and unrealistic consequences we can reduce by adding additional variables A, C, and D. Moving to question 15, which of the following statements are true regarding nested logic choice models? These models help to reduce the unrealistic consequences of IIA property of MNL model by grouping dissimilar alternatives together. If log sum parameter is 0, alternatives within the nest are said to be perfect substitutes. Value of log sum parameter can take any value for acceptability of the considered nesting structure. And so we have one more option here. So D is different values of log sum parameters indicate the degree of dissimilarity. So let's give maybe 1 minute. You can answer. Then we'll discuss the answer for this. Okay. Let's see the answer. So first is these models help to reduce unrealistic consequences of IIA property by grouping dissimilar alternatives together. So we don't group, we cannot group anything dissimilar. So group is always made in similar. So similar will do. So we can remove A. Then we have if log sum parameter is 0, alternatives within the nest are said to be perfect substitutes. So yeah, this is true because there will be a perfect correlation when theta is 0. So mode 1, mode 2, it will be entirely the same. They can be substituted for each other. So B is correct. Value of log sum parameter can take any value for acceptability of the nesting structure. No. So theta should only lie between 0 and 1. It cannot take any value. So C we can remove. These different values of log sum parameters indicate the degree of dissimilarity between and among pairs of alternatives. So yeah, this is also true because based on how theta is changing between 0 and 1, we will have different degrees of dissimilarity between the two modes or alternatives. So option B and D are correct. So option B and D are correct. If log sum parameter theta is 0, the alternatives within the nest are said to be perfect substitutes because there will be correlation And different values of log sum parameters indicate the degree of dissimilarity. So theta will vary from 0 and 1, and what is the accurate value will what is the precise value will decide the degree of dissimilarity. Moving to question 16. So we have been given the utility values directly. So this time we don't have equations. Directly we have been given the utility of car, bus and metro. So we have been given a nested logic model. Deterministic component of utility function of transit is Vt equals minus zero point 0.7 plus theta log sum, and theta is 0, where upper level choice is made between transit and car, and transit is subdivided into bus and metro at the lower level. What is the choice probability of car by using nested logic model? So we are given 0.44, 0.46, 0.55 and 0.57. You can try this. We have been given the utilities directly. Any response for the question? Okay, let's see the answer. So we have been given the values. So let's see. So Vc is minus 0.4, minus 1.1, minus 0.8. Minus 1.1, Vm is minus 0.8. So here we are saying that Vt is minus 0.7 plus theta log sum, and theta is 0. So Vt will be nothing but minus 0.7. So this term we are ignoring. So basically there is the user. So he can choose between car or he can choose between transit. And transit is further classified into two modes, bus and metro. So upper level choice is between car and transit, and then at the lower level he will choose between bus and metro. So here we have to find the probability of choosing of, I think, car. Yeah, so probability of car will be e to the power vc, e to the power vc plus e to the power vt. Because we are choosing between car and transit, here we don't care about bus and metro. So because we have combined bus and metro into transit, one mode. So e power vc minus 0.4, e power minus 0.4, e to the power transit utility is minus 0.7, which is given here. Let's find it. So numerator is 0.67. This will also be here. 0.5 almost we can take. It's coming out as 0.57. So is it clear? Hope it is clear. So we'll move ahead. Okay. So answer is 0.57. Going to question 17. So utilities are given minus 0.4, minus 1.1, minus 0.8 for car, bus, metro. So we have to find the choosing of car as per multinomial logit model. So this time we are not nesting bus and metro as transit. We are saying that, okay, there are three modes, car, bus, metro, all three are separate. So we will use a multinomial logic to find the probability of choosing car. So let's do it here itself. So BC is minus 0.4, BB is minus 1.1, BM is minus 0.8. So let's find e power VC, e power VB, e power metro. Then we can find the total also. So first is e power minus 0.4, e power minus 1.1, e power minus 0.8. So first is 0.67, 0.33, last option is 0.45. Let's take the total of 0.67, 0.33 and 0.45. It will be, I think, 1.45. Yeah. So now we need to find probability of car. So it will be e power VC by total. So e power VC is 0.67 by 1.45. It is coming out as 0.462. So you can round it off as 0.46. So option B is correct. So is it clear? Okay. So moving on. So answer is 0.46 for this question. Question 18. So we have been given mode choice between car, bus, metro. Modal utilities are given minus 0.4, minus 1.1, minus 0.8. If the returnistic component of utility of bus reduces by 0.3, what is the difference between probability of choosing metro rail by using nested logic and multinomial logic model? So what we are saying is we will reduce the utility of bus by 0.3. So it will become, so we have been given the options minus 0.05, minus 0.07, 0.07 and 0.05. So let's do this. Here we have given BC minus 0.4, minus 1.1, minus 0.8. So the new value of VB dash will be minus 1.1 minus, we are reducing it by, so it will become minus 1.4. And here we are using nested logic also. So probability of transit will be 1 minus probability of car. So probability of car was 0.57 that we found in the first question using the nested logic model. So it will be 1 minus 0.57. So that will be the probability of using transit, because this model is, so there is more choice. We have car, we have transit. So this is the up level choice. First we will choose between car and transit. And then if we are choosing transit, we will choose between bus and metro, because we are nesting the choices. Multinomial logic, we will have car, bus, metro all at the same level. So next, if we are using, let's say, nested logic model, NL model. So probability of metro, if we are taking transit, will be probability of metro by probability of metro plus probability of bus. So this will be around, I'll take the utilities. So probability of metro will be e power minus Vm, sorry, e power Vm, correct it. So we'll take e power Vm, so it will be e power minus 0.8, will be 0.45. Then we'll take probability of bus, so it will be e power minus bus is 1.4, the utility. So it will be around 0.25. So 0.45 by 0.45 plus 0.25. So this will be around 0.64. Now we have to find the probability of metro rail. So metro rail will be probability of transit into probability of metro transit. So first we will choose transit. So there will be a probability for that. And then after choosing transit, we have to choose metro. So that is PM by T. So we have to take the product because these two are independent events. So first we will choose between car and transit. And then once we have chosen transit, we'll decide, okay, we have to choose bus or metro. So there will be two probabilities which will take the product. So probability of transit is 0.43. Then probability of metro when we have taken transit. So that will be metro by metro plus bus. So within metro and bus we will choose. So that will be 0.64. So 0.64 into 0.43, it is around 0.2752, around 0.28. Now this was nested logic model. So now we will do multinomial logic model. So here probability of metro will be, so first we will choose metro. So that is e power Vm, e power Vm, e power dB, and we'll have e power Vc. So metro is, we saw here, so it's 0.45. Then metro 0.45, bus 0.25. So metro is 0.45, bus is 0.25. Car we can find. So car will be PC, e power Vc will be e power minus 0.4, is coming out to be 0.67. So we can add it here, 0.67. So this is around 0.328. We can round it off to 0.33. So what we have to find is difference between probability of choosing metro rail by using nested logic and the multinomial logic model. So delta P is probability of metro from nested logic minus probability of metro from multinomial logic. So nested logic is here 0.28, multinomial is 0.33. So 0.28 minus 0.33 minus 0.05. So is it clear? Fine. Moving on to the last question. So answer is so minus 0.05. I'll just mark it. Question 19. So we have been given the utilities minus zero point 0.4 for car, minus 1.1 for bus, minus zero point 0.8 for metro. What is the change in probability of choosing car after the reduction of deterministic component of utility of bus by 0.3 as per nested logic model? So I'll give 1 minute. You can give it a try and we'll discuss the answer. So there is no option for this. It is simply value you have to say. So as we discussed, so first we have mode, we have car, we have transit. So it is to be seen that we are using here nested logic. So we will use bus, we'll use metro. So first we have to choose between car and transit. So as we saw, that transit utility was given in the first question. So minus at 0.7 theta log sum. Let me just check it once. Yes, minus 0.7 plus theta log sum. So what change we do in bus utility, that will decide how the probability of bus or the probability of metro will change once transit is chosen. But here we have nested them. So bus and metro are clubbed together. So we have, first we will choose between car and transit. Once we choose transit, then we will decide, okay, we have to choose bus or metro. So because we have nested the two. So here we are saying that bus we will change by zero point 0.3. So we are reducing bus by zero point 0.3 utility. So obviously the metro probability will go up, bus probability will go down. That is obvious. But we are not doing any change in the probability of transit. That is remaining same, minus zero point 0.7 plus theta log sum. Theta is given as 0 in the first question. So we can take it as 0 here also. So minus zero point 0.7. So car utility is same, minus zero point 0.4. Transit utility is same. What we are changing is bus. So within bus and metro, the adjustment will happen. It will not reflect in the choice of transit. So the answer will be 0 because we are changing in bus. So it will reduce the utility of bus or it will increase the utility of metro. But at the overall level of transit, it will not affect because we are comparing car and transit. So probability of choosing car will remain the same. If we did some change in the transit level, the broad level, so then probability of car will change. But here it will not change. I hope it is clear. If you have any doubts, you can ask. Any doubts? So you want explanation for question 19. Okay. So see, nested logic, what we do is we club two modes together. So we club bus and metro in one mode, that is transit. So we have utility for bus, we have utility for metro, and we have a overall utility for transit level. So first we will choose between car and transit. Once we have chosen transit, we will choose, okay, we have to go for bus, we have to go for metro. That is later. First we'll choose between car and transit. Here what we are doing, we are changing the utility of bus. So what it will do is it will reduce probability of bus, increase probability of metro. That will happen within transit. But at overall transit level, we are not changing anything. So car and transit are still the same. So there won't be any change in the probability of choosing a car. If we did some change at the transit level, broad level, then probability of car will change. But we are not doing change. We are doing a change in the branch. So it will not change. So is it clear? Okay. Okay. If that is the last doubt, so we will close the session here. Thank you for attending.